Good day, ladies and gentlemen. I'm delighted to welcome you to this session, which will be focused on reviewing questions and answers for Aruba Certified Network Security, specifically HPE6-A78, which refers to the Aruba Network Security Associate exam. So before we dive into the questions, let's take a moment to understand our context. So 591 Lab is the leading IT training and certification exam brand in China, Hong Kong, Taiwan, and Singapore. At 591 Lab, our mission is crystal clear to provide our clients with an exceptional exam preparation experience, especially for certifications in Cisco, Huawei, Aruba, Juniper, Palo Alto, and Fortinet exam tracks. Now, let's get to the heart of the matter. Here's an overview of what we'll be covering during today's session. So starting with the license requirements, we will be discussing license requirements in the context of Aruba network deployments. After that, we will be moving to the social engineering and illustrating what social engineering and how can be eliminated within your network. After that, we'll be moving into RADSEC and its importance as it's an important aspect in the public network to secure your traffic. Moving on, we will be considering the importance and the important factors related to MAC authentication. Finally, we'll be discussing and addressing some troubleshooting scenario regarding ClearPass authentication. So the first question is license requirement. So the question is, a company is deploying Aruba OS CX switch to support 152 employees, which will tunnel traffic to an Aruba mobility controller. So for the controller to apply firewall policy and deep packet inspection, the MCU will be dedicated to receiving traffic from the Aruba OS CX switches. So the question is, what are the license requirements for the MC? So the first answer, we have one PEF license per switch and one WebCC license per switch. Second one is one AP license per switch, and third one AP license per switch and one PEF license per switch, and final answer, one PEF license per switch. So let's take it here and pen. So if we're having one switch, here's the switch and here's the controller MC. So basically, if we are tunneling traffic between switch to the controller will require one AP license per switch, and if we are to apply any firewall policies, we would need one PEF license per switch. So it's basically just like the access points in the perspective of tunneling traffic to the controller. We require one AP license for the AP termination on the controller. It's exactly the same for the switch. So whenever we have a switch, we need to tunnel the traffic to the controller. We would need per switch one AP license and one PEF license for that switch. And let's move that here. So here from the Aruba documentation, we have two deployment scenarios. The first one, 10 APs and 10 switches. The customer is using only AP license for the deployment to function. 20 AP licenses are needed in terms of only terminating the traffic to the controller without applying any firewall policies. Second one is 10 APs and 10 switches. So the customer would need PEF RFP license for the deployment to function. So we would need 20 AP license of each term. So in that case, we only need PEF and AP. So the correct answer should be pen here, C. So one AP license per switch and one PEF license per switch. moving on to the social engineering. So the question is, what is social engineering? So before we go into the answers, let's get an overview on what social engineering. Basically, it refers to any form of attack in which hackers use human to get around defenses. For example, a hacker could call an employee posing as a member of IT staff. The hacker might spin a story about problems with user account and needing the user's password to fix them. Some helpful employees unaware of this risk could give up their passwords, allowing the hacker to obtain valid credentials without having to crack anything or do any extra effort. So hackers can make similar attempts to discover other sensitive information like username, security practice, and personal information to get a closer look into that account, which would be a very valid step into getting into the network. So let's get back to our question. So what's social engineering? The answers are, hackers use artificial intelligence to mimic a user online behavior so they can infiltrate a network and launch an attack. Second one, hackers spoof the source IP address in their communication so they appear to be a legitimate user. And so that one tends to make spoofing or any kind of IP spoofing. So it's basically looks like a man in the middle attack. So hackers intercept traffic between two users, eavesdrop on their messages, and pretended to be one of or both users. It looks like man in the middle as well. So hackers use employees to circumvent network security and gather information they need to launch the attack, and that one is the most appropriate to our scenario here. So the correct answer would be D. Oh, oops. So the answer would be D. Okay, moving to the next question. And RATSEC. So what is the use case for implementing a RATSEC instead of Radius? So we have options as call district want to protect messages sent between Radius clients and servers over an untrusted network. Organization want to strengthen their encryption used to protect Radius communication without increasing complexity. A university want to protect communication between student devices and network access servers. A corporation wants to implement ETLS to authenticate wireless users at their main office. So let's get into what is RATSEC. So RATSEC helps to ensure the security of Radius so that you can deploy it over an untrusted network. Okay, so the Radius server and Radius clients use TLS to authenticate each other's with certificates and create a tunnel with strong data encryption and authentication. They then exchange Radius messages over that tunnel. So getting that the main or the closest point is we have a school district that want to protect the Radius messages before it being exchanged. Okay, so protect the Radius message before it was sent between Radius clients and servers over untrusted networks. So the most appropriate one was the option A. Okay, so moving to the MAC authentication consideration. So what is the consideration for using MAC authentication to secure a wired or wireless connection? So options are, it's very easy for hackers to spoof their MAC addresses and get around MAC authentication. As a layer 2 authentication method, MAC authentication can be used to authenticate devices to any external authentication server. MAC authentication can add a degree of security to open wireless LAN by enabling the next generation of PMK to encrypt traffic, or headless devices such as IoT devices must be configured in advance to support MAC authentication. So the IoT devices can be authenticated against MAC authentication, of course, and it's another level of adding a security to the wireless LAN, and all of these are correct. But the drawback or the consideration we have to bear in mind is that Mac authentication doesn't provide that from one of the Aruba documents, and it's common and very agreed between all vendors because it's very easy to spoof any of the MAC addresses. So theoretically, first it identifies the device only, not the user on the device. So the MAC authentication refers to the device itself, not who is accessing the device. So if I'm a hacker and I'm doing a man in the middle and I got your MAC addresses, I can basically spoof that MAC and get the same level of access in the network using that your MAC address without any additional effort, rather than we can get into the device physically and can get the MAC address. Say we have printers, we have scanners, we have cameras, we can, the MAC addresses for these devices are stacked on usually in front of the device, so I can spoof that MAC address and get into the network. So the main consideration for that would be it would be very easy for hackers to spoof their MAC address and get around MAC authentication. So the correct one would be A. Okay, so for key pass authentication, we have a use case here. You are troubleshooting an authentication issue for Aruba switches that enforces 802.1x to a cluster of Aruba ClearPass policy managers. You know that CPPM is receiving and processing the authentication request because the Aruba switches are showing access rejects, so that is an attribute being reverted to the switches in their statistics. However, you cannot find any record of the access rejects in the ClearPass tracker. What's something you can do to look for the records? So go to ClearPass Policy Manager Event Viewer, because this is where release access rejects are stored. So the question is saying you cannot find any record for the access rejects in the ClearPass access tracker, and it's showing an access reject in their statistics. So it's the ClearPass have responded this one and it shows as access reject. So the event viewer will get a record if you have a mismatch on the radius shared key or something like this, but it would go, if the radius shared key is okay and the reject happened, it would definitely go to the access tracker, so this one would be incorrect. Verify that you logged in the ClearPass Policy Manager UI with read write, not read only access. So the access tracker is basically read privilege. It doesn't require any write privilege, so this one also will be incorrect. Make sure ClearPass cluster settings are configured to show access rejects. So that will be basically if you are on ClearPass and you get any kind of record on the access tracker, you would show that by default it shows that your request is approved or rejected. So this one is not correct as well. So the last one, click edit and access viewer and make sure that the correct servers are selected. So let's get that one here to illustrate. So if you edit the servers, for example, it's a cluster, ClearPass Policy Manager cluster, so it's a multiple, let's say it's 2 servers, okay? If you selected the secondary one and the switch sent the authentication to the first one and the first one rejected the request, it will not show, of course, on second one unless you check that one, or you better click on see post default servers, so you see post authentication records. So the most correct answer would be D for sure. Okay, so in conclusion, I would like to extend my heartfelt thanks to each and everyone of you participating in today's session at 591 Lab. We hope you found the material not only informative but also valuable for your journey towards certification success. Remember, when it comes to mastering new skills, practice is paramount. Take the time to review the course content and keep practicing with the support of 591 Lab. Should you have any question or concern, don't hesitate to reach out to us. Your active participation is deeply appreciated, and we eagerly anticipate seeing you in the upcoming classes. Thank you and have a great day.